Hello class, welcome to our second lesson dealing with section 7.2. We're going to be looking at the population proportion estimations again. You want to make sure you know how to find the confidence levels and confidence intervals for these situations. We're also going to work backwards a little bit today. So let's go and get started. First thing we're going to look at is determining sample size. Now, oftentimes when you're dealing with collecting data, if you were in some experiment or things like that, you'd want to know before you start the process how many people you should ask the question to. That oftentimes will solve the issue in terms of having issues later on with like central limit theorem and things of that nature. And so essentially we just solve the margin of error equation for solve for n. You won't have to do that yourself, so the next slide will have that information. The important thing is when you find n, you always want to round up. So even if it's like 100.1, you round that up to 101. And the reason for that is you have to make sure to include that many people in your sample or subjects in your sample. And so you have to round up to make sure that you've got enough space. Okay, here's the formula. This is for proportion questions. So it's solving for n. So it's the z-score for the confidence interval we're talking about, okay, squared, times p hat and q hat, which are when the population or when the point estimate, of the sample is known. When that information is known, you use that information from p hat and q hat divided by the margin of error squared. One thing about the margin of error is typically it's a percentage. You got to make sure it's a decimal before you plug into the formula. If there's no known p hat or point estimate, then you use 0.5 for both. Now I hesitate even to show this formula because really what you want to know is that p hat and q hat are both 0.5. Well, if that's the case, every time you can do 0.5 times 0.5 and you'll get 0.25 for that number. And so when you're dealing with these situations, really it's this first formula that you're always using. It's just if there's no known estimate, you use 1/2 for both p hat and q hat. Okay, so here's an example. We're trying to figure out how many adults walk at least a mile a day. So you want to be 95% confident. It says that the sample percentage in error should be no more than 3%. So 95% confident means my z-score is going to be 1.96. And then within 3 percentage points, my margin of error then is 0.03. Remember, make that a decimal. Now, one thing students struggle with these formulas is they try to plug in z as 1.96 and then like divide by 2 in these pieces. Remember, this alpha level is just what the extra pieces, the outside parts, which is the 0.1 or 0.05 when I divide by 2. You shouldn't have to deal with that for any question with the z-score formula for this section. So when you find that, it's just 1.96 and then square it. There's no information prior knowledge, so we use 0.5 for p and q, and then divide by 0.03 squared. Plug all that in, I should get 1061.1 repeating, which rounds up to 162. Okay, that situation when I'm rounding those questions is what you want to find. And then that would be how many people you should ask the question to. Now, if you take that exact same information and then say some reputable website or company or nonprofit, okay, whatever it is, has some information already for you. So this says that the World Health Organization says 62% of people walked at least a mile a day. So now there's some prior knowledge that we have already. And so instead of 0.5 and 0.5, I'm going to use 0.62 and 0.38 because they add to 1. Notice everything else is the same. 1.96 squared, 0.03 squared for the margin of error squared. And notice this number goes down to 1006. That makes sense because this version was the most people I'd ever have to ask if I knew nothing else before I started. This one says, okay, now I know some stuff. Find the answer for me. And this one would round to 1006. Whenever you find the sample size, make sure you have margin of error, whatever confidence level you're dealing with, and then p hat and q hat if known, and if unknown, use 0.5. There's some other questions from your homework that just deal with how to find the point estimate, how to find the margin of error. Essentially, to find the point estimate, you just take the upper limit and the lower limit of the class and divide by 2. Essentially, you're finding the midpoint. Okay, if you think about it like kind of a low end and high end in the middle, that's where the midpoint should be. The margin of error is the same thing but subtraction, and the reason is you have to find the range of the data and cut it in half because the margin of error would be half in each direction from the middle. And so that's why that idea would work. Some of your homework questions just talk about some of those pieces and ask you to find them, and then you should use those to help find your answer. So if we go back to our first example, we had the population proportion, and our estimate for that was this 0.677 up to 0.723. The point estimate would be found by adding those two numbers and dividing by 2, and my point estimate is 0.7, which I already knew because I told that information to you, but if we had to work backwards, that's where it would come from. And then the margin of error would be subtraction of those two things divided by 2, and you get 0.023, which is what we dealt with yesterday or previous day's lesson about how to find the margin of error using the formula with z-scores and p-hat, q-hat, etc. Okay, so here's another example just to kind of go through. Notice here that I'm giving you a percentage to look at. And so this says find the 99% confidence interval for the population proportion P. So if it's 99%, we're going to use a z-score of 2.575. And so my margin of error would be found by the z-score, which is 2.575, times the square root of p-hat times q-hat, so 0.85 times 0.15, divided by n, and square root it, which would be 1005. I plug all of that in, and I get 0.029. Remember, this is a percentage style question, so it makes sense that these margin of errors are going to be very small because that's 2.9%. So then my confidence interval is 0.85 plus or minus 0.29. That's one way you could write it. Another way to write it would be actually adding and subtracting, which I tend to do more often, so then I can see the range of numbers that are the high and low end. So based on the results, can we conclude that 75% of voters actually voted? And we could say yes, because 75% is not in my range. My range is from 82 to 87, or almost 88%, and that's all above 75%. So I can safely conclude with 99% confidence that more than 75% of voters actually voted. Remember, the conclusion here, it would be we are 99% confident that the true proportion of people that voted in the last election is between 0.821 and 0.879. When you're looking at your homework questions, you want to make sure that you understand how to find p-hat. Okay, you might have to divide to find that. We'll deal a little bit more with that next lessons. But you may have to find p-hat by taking the data set and saying successes out of total, kind of like a probability idea. Then you have to make sure you can find the z-score, which most cases should be one of the three, 90, 95, and 99% confidence interval, and then use that to find the margin of error. Make sure you can come up with the conclusion like what we just mentioned. You're going to have to do that on a test as we move forward in this section. Have a good day, everyone.